Hi, thanks. Thanks everybody for coming, and thanks Chris for starting this webinar training off. If you could do me a favor, Chris, and let me know if people have a lot of questions and I need to pause or take a look at the questions, please let me do that because I want to be able to make sure that you guys understand what I'm talking about, what I'm trying to explain as I'm explaining it. Without further ado, let's get into today's training, which is just an introduction on InfluxDB and Telegraf. So today I'll be going over some basic concepts about InfluxDB, kind of just what is it and what is Telegraf, and then most importantly, how are they used together and how can you use kernograph. And yeah, that's pretty much it. So InfluxDB is a time series database, and it was built from the ground up to specifically handle really high writes and query loads. This custom performance is really specifically made to handle things like IoT data or DevOps monitoring, any data that you have a timestamp attached to it, and especially data where you have extremely high volume of that data and you are interested in looking at it as a live stream. InfluxDB manages to conserve a lot of space on your machine because it has these features called retention policies. And I'll go into more detail about what retention policies are, but essentially they allow you as a user to automatically expire a lot of your data after a certain amount of time. Because for a lot of us, old data isn't really that useful. So with retention policies, we can say, okay, after this amount of time, I don't care about this data, go ahead and just automatically delete it. And then in doing so, we can save a lot of space on our machines. Also, alternatively, you can perform things like downsampling, which will enable you to only retain summaries of your data instead of the raw precision data. And this is another way that you can conserve more space. So these are two elements that allow InfluxDB to be very high performant and safe space saving. But later we'll also talk about time series indexing and how that also enables users to handle really high write and query loads. Finally, InfluxDB offers a SQL-like query language. So I had only really used MySQL and also MongoDB before coming to Influx, and I found it very easy to understand InfluxQL because it's so similar. And the differences really made a lot of sense to me too. I think they were actually a little bit more organic than some of the SQL syntax. So maybe that's just because I've gotten used to it now, but I think it makes a lot of sense if you're familiar with SQL. Let's see. So Telegraf is really cool. It's our most open source tool, and it is an agent for collecting and reporting metrics and events. So it is plugin driven. Sorry, excuse me. It is plugin driven, and I said it's our most open source tool because we have about 160 plugins, maybe more, and we've only written a handful of them. So the community has really contributed the rest of these plugins, and that's partly because it's all written in Go, and it's installed as a single binary. So it's really easy to make sure that you have all your dependencies. And if you've ever written anything in Go, you'll know that Go has fairly strict requirements for how your workspace is set up. And these strict requirements enable users to read other plugins and read other code and quickly understand how to write one and be able to model their own plugin that they want to write based off of something that they're reading. But also it ensures that you are following this strict workflow and workspace requirements so that you have structure when you're writing your own. And so for these reasons, it's been contributed to a bunch. And then also that it's very lightweight, and it allows you to grab metrics from a variety of different input sources, from APIs, or maybe the system that it's running on, or you could also get metrics from StatsD or Kafka. And then you could take those metrics and send them to basically whatever you want, not only InfluxDB, but also Graphite or OpenTSDB, Datadog, Vibrato, Kafka, MQTT, etc. So I like to suggest to people who are a little bit shy about trying InfluxDB to go ahead and just start with Telegraf, because you really don't have anything to lose and you can just kind of plop it into your pipeline at any point. So in order to use Telegraf and InfluxDB with Chronograph, Chronograph, by the way, is just our UI tool. You can create really beautiful dashboards and visualize your data in it. You need to install and start InfluxDB. These slides, I think, will be more useful to you once you get the recording, because then you can actually follow these instructions. But here they are for Telegraf, and here they are for Chronograph. And then once you visit localhost 8888, then you just make sure to attach your Telegraf database to it, and you can give it a name. And so once you've added that source, you want to go to your host list and make sure that the status is good and that you have established connection. And then you can go ahead and make awesome visualizations in this cool, dark layout. So it's pretty self-explanatory. There's a cool, you can see my mouse, right?
Can you wave it around? Yeah, you can also use the annotation if you want to in Zoom. If you go to the top, there's you can grab the pencil if you like doing that.
Okay. Cool. Oops. Well, now I'm going all over the place. But basically there's an option to explore your data to begin with. So you can kind of visualize what query you need to be creating for the dashboard that you want to create. And then you can just copy that query once you've explored the data and then plop it into a dashboard. So it makes it really simple. Also, another wonderful feature is at the top here where it says every 5 seconds or past hour, the date picker is really nice too, because a lot of times I can't personally remember when and where my data is coming from. And so for me, I really like when I'm first exploring my data to just start out by using a custom date picker. I'm also really bad at converting, for some reason, the numerical date to the actual month in my head sometimes. So I don't know, I find it useful. So in order to really talk about InfluxDB and some of the special features like shard groups, retention policies, TSI, these are all things I'll go into in a little bit. We first need to go over some basic terms and terminology. So a database has one or more series, and a series is defined by a value and timestamp pair that shares both a measurement, a tag set, and a field set. A field set you can think of as having a collection of the field key, which describes your value, and the value itself. So it's kind of like the meat of the series in a lot of way, in that it is where you're going to be putting your numerical value, most likely. And then your tag set will be a collection of tag key and tag value pairs, and these will help you define and describe your data. Tags take a little bit of time to explain for people to really, I think, wrap their head around in terms of how useful they can be and how much they should be utilizing them. But I like to tell people that tags are really your best friend, and you should put as many tags as you can. And I will talk a little bit later about how you can use Schema design recommendations and kind of work from those recommendations backwards to figure out just how many tags you can include in your database. So measurement acts as a container for fields and their types, and a point is a combination of a measurement, a tag set, a field set, and a timestamp. So let's go into some examples. So InfluxDB requires that you write your points in what we call line protocol, which follows this format. So in this example, our measurement would be CPU load, and our tag key and tag values would include the host name and the region. And then we have our field key and field values, which include our temperature and our voltage. And finally, we have a timestamp associated with it. So that's how you want to ingest any of your points. So let's go into a little bit of a better example of why you want to create different series by assigning different tags. So let's pretend that I am heading a research group and I want to create a census for the amount of butterflies and honeybees that are in 2 locations. Location 1, let's say, uses pesticides and location 2 does not. And I also want to monitor the performance of my scientists. So in this case, I would create a measurement and I'd call it census. I would create a field set, and these field sets are going to contain the items that I'm interested in measuring, primarily butterflies and honeybees. And then because I want to track the performance of my scientists, I would create one tag that would be labeled scientist, and then I would associate the different names of my scientists under that tag as different options. And then I would also include the 2 locations. And one powerful part about retention policies is that you can actually assign retention policies not only to measurement, but you have higher granularity with retention policy. You can actually assign them to a specific series. So why might this be useful? Well, if location 1 is incorporating the use of pesticides, I might have a dramatically lower count of butterflies and honeybees in that location. So if I'm interested in retaining virtually the same amount of data at any given point for location 1 and at any given point in time for location 1 and location 2, then I would set my retention policy for any series that contains location 1 to be much longer, so that I actually have enough time to gather a similar amount of data as I do for location 2 or series 2, where they don't use pesticides. And then that's pretty much all I have to say about that. So when you are creating your schema, you want to have the following considerations, which is that first and foremost, that tags are indexed and that fields are not. So any queries that you want to perform where you're filtering, you want to filter by your tags. So tags will really be able to help you describe your data and add higher granularity filters to your data. And you can do that by including group bys in your queries and grouping by a tag. And then you can gain further insights into what's going on. Also, field types are immutable, so that's just something to keep in mind. You can't switch. And then if you want to use InfluxQL functions, these are things like finding the min, max, average. There's even predictor, Holt Winters. There's a lot of different basic InfluxQL mathematical functions. You can use them on fields and not tags. So any sort of math that you want to perform, just know that don't store that information in tags. And then as a result of tags being indexed, they're going to be a lot faster. So just keep that in mind. You can query by a field, but it'll be sort of painful, or a little bit more painful. And then finally, you really want to be aware of series cardinality. I will go into details about what series cardinality is right now. So it's the number of unique databases, measurements, and tag set combinations. So here we have a really simple example. Let's pretend I have 2 tag keys in my measurement called email stuff. Well, for my 2 tags are going to be email and status. And for both of those tags, I have Well, for email, I have 3 different options, and for status, I have 2. So in order for me to figure out what my series cardinality is going to be, I just have to find out what the total number of options are. So in that case, it's going to be 3 for Lore, Marv, and Cliff for the different emails that I have available for me, and times 2 for the amount of different statuses I have. So I'm going to have a series cardinality of 6. And this doesn't really mean much right now because you're like, series cardinality is 6, that can't be a problem. But let's look at this real life example. Let's say that I have 2 tag keys, container ID and process ID. And for each of these tags, I have 10,000 possibilities. Well, now if we're going to multiply all of my possibilities together, you can see that if I were to assume that each series were to take up like 1 kilobyte memory, then I'm like really quickly running out of RAM. So we like to call this runaway series cardinality, but we've mitigated this issue with time series indexing. So what that is basically it allows you to move your indexes onto disk to conserve RAM, and it only retains the hot shards or your data that you're like currently using that's current in RAM, and the rest of the indexes will be on disk. And I will go into, I talked about this earlier, but I'll go into an example of how you can backtrack and figure out just how many tags you can have available. But I think the main takeaway from this is that the amount of fields that you're going to have, that's just something that you don't really have, probably won't have much of a say on. Whether or not it's IoT or DevOps, like you're going to have to gather a certain amount of metrics and events. Where you can influence your series cardinality is in the amount of tags that you choose to create. So I think that's where a lot of your power in your schema design is. What else did I want to say about this? I wanted to also share that before TSI came out, we could only put about 50 million writes total into the database. But then after we created TSI, we were able to put 700 million writes. This isn't per second, this is just total. And startup time used to take about an hour, and now it's pretty much instantaneous startup. So that kind of helped me visualize just how powerful TSI was. And also, I found it really interesting that is the volume of data that people are collecting, that even the index needs to be stored on disk. I found that really fascinating, just because it's hard for me to wrap my head around such large numbers, and that kind of really brought it home, just in terms of like how much the database can handle. So we talked a little bit about retention policies earlier, but they basically help you describe how long you want to keep data for. And also, in the enterprise version, they allow you to specify how many copies of those data you want to store on a cluster. So they're going to be unique per database, but they're also going to be unique per series. And when you create a database, you automatically have a retention policy that has an infinite duration. But the syntax for creating a retention policy looks like this. You just say create retention policy, and you specify the policy name, on which database, for what duration do you want to keep the data. The minimum is 1 hour and the maximum is infinite. And then you say if you want to replicate different shards, and that's pretty much it. So another part of understanding InfluxDB is understanding shards and shard groups. So the way that InfluxDB is able to be very efficient is that you can drop data in batches. And the way that batches are defined is from shard groups. And the way shard groups are defined are by their shard group duration. So I will exit out of this to show you a different example because I personally need some sort of visual cue to really understand what's going on. So here is an example where you have a lot of different series coming in, and let's say you have set your replication factor to 1, and you also only have one node. Well, this is like your open source version. This is out of the box. What's going to be going on? Basically, in this case, if you set your shard group duration to be 10 seconds, then your shard group will have all of these series. And since you said I only want one copy of all of these series on one node, then your shard will contain every single series. But now let's say, for example, that we have 2 nodes because we're in the enterprise version, and we say we don't care about having a copy. We just want to have a replication factor of 1. Well, in this case, we will see distribution across the nodes. So our shard group will still be defined by the duration, which is 10 seconds. Is this big enough? Can everyone see this?
Yeah.
Okay, cool. And then as a result, the series will be distributed to each node. So series A will go to node A, and then series B will go to node B, and then series C will go to A, and D will go to B. And so that's something that you don't have to worry about. This is just how the database handles distribution and shard groups. But I find that looking at this example, I recommend reading this blog if you have more questions too. Really helps clarify the relationship between replication factor and shards and shard group durations. But in general, there's other things to know about retention policies is that they drop the entire shard group, not individual data points. And so as a result, you might be able to improve your write speed by increasing the size of your shard group duration. Because if your shard group duration is too small and you're constantly writing points and dropping points in really small batches, then that's equivalent to writing points individually. So you want to take a look at how much data or how many series are in your shards in order to make sure that you are taking advantage of its ability to drop and write in batches. So the recommendations that we give is that each shard group duration should be 2 times your longest query time range. So if you, for example, are trying to monitor, let's say, hits on your website, traffic website, then you know that every weekend you have a spike. So you might want to make your shard group duration 2 weeks. And then also, let's say you have each shard group should have at least 1,000 points per shard group, or 1,000 points per series. In other words, you should have around 100 series. So let's pretend that I have like 25,000 different fields that I'm trying to measure like per minute, or 25,000 20,000 response codes or something in a month. And now I want to figure out just how many tags I can assign when I'm creating my database. This is kind of what I was talking about earlier. You can use these considerations to figure out how many tags you want. Well, you can say, okay, I have 25,000 points that I am gathering in a month, which is my shard group duration, because that's what I'm interested in querying. So now I can say to myself, well, I can have 2 tags, let's say, and each one of those tags can have 2 options. So I can have a total 2 times 2 is 4. And then now 4 times 25,000, that gives me 100,000 points. So that's how I can work backwards to say, okay, well, that means that I can assign 2 tags, and they can each have 2 options. I hope that made sense. So if you want to mitigate any storage concerns that you have because you're keeping data for a really long time, you can use continuous queries to perform downsampling. So there are 2 ways that you can do this. You can either use a continuous query directly in InfluxDB, or you can use Kapacitor as a continuous query engine. So Kapacitor is our processing engine. It can do pretty much anything that you want because you can write these useful things called tick strips, and you can pre-process your data in any way you want, or create predictions, or run other Python scripts on your data. The options are really limitless, but part of what you can do is also create continuous queries. So people have a lot of big question typically of like, when should I use Kapacitor over just writing a continuous query in InfluxDB? And what we like to say is that, well, if you're already using Kapacitor, then it makes a lot of sense to just give that workload to Kapacitor, especially if you want to write a lot of different continuous queries, then you might as well use Kapacitor. But if you're not, and you're just writing a handful or a couple, then it just makes sense to write your continuous queries in InfluxDB. Also, yeah. So InfluxQL, like we said, it looks like SQL. You can use select count all, which is what people like to do when they finally get data into Influx and they're excited and they want to see it. But you just want to make sure that you understand that, take a step back and look at what you're doing, because if you're using time series data and you do select all, you're going to be really sad because you're going to be running that for quite a while. So you always want to consider the scope of your query. And you can do that by either grouping by a certain tag, which will limit it, or more specifically, it's a good idea to either say like limit 100 when you're first investigating to make sure that you successfully gather data into Influx, or alternatively, you could just limit your scope by limiting your time range. And yeah, just always include a time range so that you're not sad and stuck in purgatory while Influx is trying to look at every single point that you've written. So there are a lot of InfluxQL functions that you can use. They include selectors, transformers, aggregators, and even a predictor. So we have, for our selectors, you can select the min, the max, percentile. And for transformers, you can do things like cumulative sum or moving average, which is obviously really important for time series, histogram, difference, etc. And then for aggregators, you can do things like apply a count, standard deviation, spread median, integral, etc. And we also have the ability to, or out of the box, you can use Holt-Winter's predictor to apply some predictions on your time series data. Additional capabilities, we handle regular expressions, and you can use also this line to point at a tag key that includes part of an expression. For example, if you don't quite remember what your tag key is in its full length. And then you can also include mathematical operators to perform addition, subtraction, etc. And then you can also use subqueries, which are a lot like SQL having clauses. So an example of a subquery is kind of like select max from max mean, let's say, from select mean passengers as a mean from a certain schedule, a certain route, and then group by that subway. So that's kind of one example that I can just think of off the top of my head. So let's talk some more about Telegraf. I went over this a little bit earlier, but Telegraf is an open source plugin driven cannot say that today. Plugin driven server agent for collecting and reporting metrics. And it's push and pull agnostic, so you can use either one. And you can batch metrics from a lot of different sources in order to reduce your number of atomic write requests. So that helps reduce your load. And also a lot of people like to use Telegraf kind of in a fan-out pattern and use a lot of different Telegraf agents that are collecting data from a lot of different sources. So you can do that too. There's a large collection of plugins. They span from not only input and output plugins, but you can also find aggregators and processors. And in this way, Telegraf acts not only just as an agent or a collector, but also an ingest pipeline. I really recommend also checking out their trainings on how to write your own Telegraf plugin. I think it's a pretty good way or easy way to contribute and also practice with Go and also write something that could be really useful for people. It's also, I would also recommend just checking out all the plugins on GitHub and just taking a quick look through them, because you might be surprised and find something that works really well for you. And I'm also, as I get more and more comfortable with Telegraf, I'm increasingly surprised about how easy it is to use. Like a lot of times I find that I simply just download the config that has the input plugin I want and the output plugin, and it just works, and I don't have to do a single thing. I don't even have to change any of the configuration variables because the default ones are already the ones that happen to work for my machine. And so like within just a minute, I'm pulling data from, for example, I just used like the Docker Telegraf input plugin recently, was immediately getting stats on my containers. So yeah, it's pretty easy and I really like it. And it's got a cute tiger associated with it, as you can see in the upper right corner, which makes me love it even more. But you can ingest metrics from both the host system, but also common programs like Hadoop, Postgres, and Redis, and a lot of third-party APIs, including MailChimp, CloudWatch, Google Analytics. Like I said, you can output plugin metrics to a lot of different data stores, not just InfluxDB. So if you're shy about using InfluxDB, go ahead and send them to Graphite or any of these other ones, Prometheus. And yeah, I've been over how many plugins we have. It's cool. It has a minimal memory footprint too. And also it was specifically written to handle tagged metrics. So if you're going to be tagging your time series data, which is a good idea because that allows you to have higher visibility into your data and allows you to perform granular filters on that data, then it makes sense that you want to use a collection agent that was specifically written to handle tagged metrics as opposed to metrics that are uniquely namespaced. Like I've also talked about, it has really easy contribution functionality. I recommend watching the training and finding something that you want to contribute yourself and going for it, because it's really pretty simple. And lastly, because the community is so large, there's a ton of help available to you if you do decide that you want to contribute to a plugin. So you can go on our community site and ask questions, and a lot of times I find that someone else from the community will have answered someone's Telegraf question before anyone on our engineering or DevRel team has a chance to even get to you. But we are always on there. There's like 10 to 15 of us that I see on there like pretty frequently, pretty often. So we will try and answer your question immediately. I want to just provide some examples of some Telegraf plugins to kind of give you more of an idea of what's out there. So StatsD listens for any data in StatsD format. Postgres is really popular and it collects performance metrics about Postgres. We have Apache as well as Nginx plugins, and for any window users out there, you can use WinPerf counters, and that will allow you to collect performance data on your window machine. Talked about Nginx. We also have an histogram plugin, which will create histograms for you. We have a Prometheus client plugin and also Kubernetes one as well. So I guess that's all. I didn't realize it ended so quickly, but that's all for me. Should we go to questions?
Yeah, please do. I'm actually trying to type out the answer to this one question, but go for it. Read them out loud and let's go.
Okay, so I have here, is it possible to connect one Telegraf to multiple InfluxDB instances and route input plugins to output plugins based on predefined rules? I'm not sure what you mean by predefined rules. I've only ever specified one database for that my Telegraf plugin sends metrics to InfluxDB. I think you can only specify one database.
No, you can specify multiple, but the only question I have is the predefined rules. I wasn't sure if that meant something else besides that. So I'm just going to type in the configuration in just a sec so everyone can see that. So let's just carry on.
Can you share some examples of Telegraf implementing processing and which plugins could do this job? Like aggregators, pre-processing in terms of pre-processing your data. I'm not sure if that's what Hassan is asking, but if you are, the histogram is a good example of that, because it will create histograms from your data and then send those histograms to Influx. Do you have a plugin to get events and metrics from a Micro Focus operation bridge agent? I have no idea. I would have to look on GitHub and see. Do you know if we do?
Sorry, I was just typing and not listening. So let's see. Do you have a plugin to get events and metrics from Micro Focus? Oh, I have no idea. We'll have to definitely look at that. Yes, and Hassan, the plugin directory is, you can either go to the docs. Let me try to pull that link for you, or GitHub, and you can take a look at that. Let me just get out full screen and let me pull that for you. And then I threw in the example on how to share to multiple InfluxDB. Hopefully that answers your question. The only part I just wasn't sure about is the second part of that question. So if you can clarify that, or if I helped you, then let us know. Okay, so we have, here is a link to, so I'm just going to put it in the chat, Hassan, so everybody can get that just in case everyone's not looking. Chat. So in the docs, we have a list of all the plugins, and you can take a look there. And then also you can take a look in GitHub if that's your preferred method. So let me just grab that as well. And another thing I want to mention about what's kind of cool about Telegraf is that if you take a look at our announcement, oh, shoot, yeah, this is what I get for trying to multitask. Let me just be quiet for a second. Okay, there's the link. One of the things that's kind of cool about Telegraf recently is that Microsoft Azure Monitor, it's a monitoring tool that comes with Azure. And they decided that they really like the Telegraf project, and so they now actually support Telegraf. And so you are able to use those plugins with Azure Monitor, and which is makes it just a lot easier for everybody. And then all the metrics get collected into the Azure Monitor database. I think the retention of the data is a little bit short, so there is also an option if you want to switch out the backend to InfluxDB or Enterprise or Cloud, so you can also do that as well. Okay, let's continue on. So let's let Hassan, you also asked, can you share some examples of Telegraf implementing processing and which plugins could do the job? So yeah, I think we need just a little bit more information about processing, and then I think we can answer that correctly. Guillaume, we'll get back to you on this micro focus operation bridge agent. I don't know anything about that, but we'll do a quick look. Hassan, I pushed the plugin directory, or at least a documentation in the chat for you. Ricardo asks, following Mauricio's question, is it possible to use Telegraf as a router? For example, to create a rule that depending on the incoming metric, it would route to a unique output. Somebody else asked something similar recently, and I don't remember the answer, but I'm going to throw that into community, and then I'm going to bug our Telegraf guys to answer that, because the answer is yes, but I know there were some other things behind that. So let me just throw that into community, Ricardo, and get back to you. And then also bug Daniel and Greg to see if they're not up and can give us an answer. Is it possible to inject data from another collector to InfluxDB? Luis, I think, so the answer is, if you're using any of our client libraries, I guess those are other collectors. You could definitely insert them into InfluxDB. As Anais mentioned, the key thing is you have to be able to support the format that we have. So as long as that's supported, then you can insert it. So that collector would have to be able to follow that. And Hassan asked, are there video tutorials on Telegraf? Yes, there are a number of them, and if you can also paste that link in the chat, Anais, I think that would be useful for everybody.
There we go.
Joseph asked, novice here, what are the most common issues you've seen users face when using a new standard InfluxDB instance? Oh, that's a great question, Joseph. I think I'll answer first and then ask Anais to chime in. I think the thing that I often see is that people just start pumping in data, not thinking about what the data looks like and what they're actually pumping in. And they get maybe a little bit too excited. Well, there's two things. One is because they don't think about what the difference between a tag and a field is, they will sometimes actually put data in as a field when it should have been in as a tag. And so when they're trying to do queries or trying to group data, then they're not able to do so. So it's just important to just take just a few minutes to take a step back to think about, okay, what am I trying to do with the data once it's collected? What do I expect the reports to look like? How do I want to be able to, what combinations of data do I want in these reports? You just have to take a few minutes to think about that. I think the other thing that I also see is that people get really excited by tags, and they just tag, like they'll put every single thing in as a tag. And what can happen is if you just go a little bit too overboard, then you will hit some cardinality issues. And by overboard, I mean like people will put in hundreds of tags for a server, and then you have to just kind of think about, do I really need that stuff? I mean, what are the things that you're really trying to do with your data? So they just get a little bit excited, and then they realize after they take that step back and look at the data that actually they don't need all that information. So then they can pull back and be a little bit more judicious with their info. What else would you say to that question, Anais?
Yeah, I would also say that it's important to remember that you can't do functions across measurements. I think people come from a relational space and they kind of think of a measurement as being like a different table. And that's not really the way to think of it. You really want to include that information by labeling it in a tag. So yeah, just taking a time to really understand that and look at other examples of, I think the CPU load example is okay, but I really prefer the scientist example. So whatever you can find an example that really makes a lot of sense to you personally and helps you wrap your mind around this space. And just, yeah, like you said, just understanding that before going further.
Cool. Let's see. Why don't you read out the question from Sajit?
So how are field key values used? In your example of CPU load, you had voltage is X, temperature is Y. As I remember, only tags are used for indexing. Can you have some use case? I'm a little bit confused about what you're asking about. The field keys in this case would be voltage and temperature, and the values are X and Y. If you could maybe clarify.
Well, maybe come up with some other examples so it can be maybe clearer. So
I guess the other example that we went over was like the scientists and butterflies examples. So in that case, our two tags that we were interested in looking at was the location and the scientists. So those were two tags, and then our fields were butterflies and I think it was honeybees, and those were each integers that we were collecting because we were collecting a count on the honeybees and the butterflies. And I think our measurement was like a census or something like that. So for another example that I'm thinking of off the top of my head, let's say you were trying to count the amount of people that were entering your various stores, then you just might have a field that says count, and then you would have a tag that says stores, and they would be, bakery, supermarket, restaurant, and your measurement would be traffic. So that was a silly example, but hopefully helps you wrap your mind around it a little bit.
So another one that I like is that we had a user that was collecting latency metrics. And so so what the tags that they added were things like data center, I think host name, customer names, because it was this is actually an example from a hosted secure email service, and so they wanted to figure out what was actually causing some latency issues, and so they ended up tagging it by 4 specific tags to help them try to pinpoint what it was, and it ended up being that it was not only was it the customer tag, but they also tagged it just as they were doing this troubleshooting by individual customer names, and actually found out that it was one particular customer that was causing like 95% of the latency issues. So they were able to then dig into that and address that. So that's another example of tags that I thought was pretty cool.
Yeah, or like for this Docker Telegraf plugin I'm using, different tags are the different container names, and the fields are, CPU or system usage, percent usage, or something like that. So.
I'll let you keep asking. I'm going to try to find some of the answers for some of the other ones. Go ahead.
Okay, so we have Telegraf running in several Docker instances, sending data through socket writer listener to a main Telegraf connected to InfluxDB. Is there a better recommended option to send data between two Telegraf? Huh. I don't know. Good question. I will have to bother someone about that. Let's see. Evan asks, can a script be used to input data directly into InfluxDB? Yeah. You can use a client library and write data directly in that way. If you're really new to InfluxDB and you just want to play around taking serial data and trying to figure out how to get it into InfluxDB. Yeah, you can check out the different client libraries. I would look at that and do that and try it out. You can also take your data in whatever format it is, write a script that will convert it yourself to line protocol, and then use the exec plugin to take that data that is in a text file that's in line protocol and send it to Influx that way. Or if you're going to be appending to that text file and you want to do it all yourself, you could use a tail plugin, and that will listen for any new lines that you put that you include to that text file. So both Prometheus and InfluxDB are time series databases, Ricardo asks, but seems to me that there are quite some differences between them. Which ones, in your opinions, are the main gains from InfluxDB over Prometheus? And I wonder if you can recommend any articles that does a benchmark on their performance. I will try and find an article for you. We like to call ourselves the official long-term storage solution for Prometheus. So Prometheus really is more better at handling ephemeral data, where we can really keep your data forever. So I think that's like the main distinction between us. And then we also offer like, well, I don't know, Chris, what else would you say is like in a nutshell is the
I think it depends on you know what your actual use case is. So we have so if it's just monitoring of like infrastructure, containers, and whatnot, they're both going to be efficient at that. We actually support the same mechanism. Actually, Prometheus actually told us to do this. The same kind of scraping mechanism that they have. So you don't need to use a Telegraf plugin. Basically, we're going to do a service discovery and then be able to pull the metrics into InfluxDB. That's the same mechanism that Prometheus uses. Prometheus is not going to keep the data around for a very long time. That's not the intent of Prometheus. And so, as Anais was mentioning, what some customers have done is if they've already implemented Prometheus, but they do want to keep the metrics around for a long time, then they dump them into InfluxDB so they can store them. But I think it's just their use case. I think we have a number of users that use both, and you know, they just feel that that tool works in their situation. I don't think you know, we don't have any benchmarks that are going to say one's better than the other. And we have no plans to do something like that as well, because I think they're just both unique, and they need to be used in a way that's going to make sense for your infrastructure. I'm sorry if that sounds like, you know, kind of a long-winded answer saying that no, we don't have benchmarks, but we do have some docs that we can send to you, so that describes that probably a little more eloquently than what I just said. There was a question about the syslog plugin, so I threw that into the chat. So we do have a Telegraf syslog plugin that allows you to pull those into InfluxDB, and then you can display them and use them for troubleshooting. So the whole idea actually the intent behind that is that we want to make sure that we can pull in as much information as we can in your troubleshooting efforts. So there's also some users that are pulling in traces as well. So it's like they're looking at the metrics, and that's indicating that something's wrong. They can then look at the syslog info, and then also, if necessary, look at the traces to determine what action needs to be taken. So it's not meant to be a long-term store for logs, but it's definitely a great use case in that scenario that I described. And we will have a talk specifically from a user on that, on how they have been successfully able to find a lot of OOMs in their infrastructure by using that. So that's the answer to that, Ahmad.
So also, Ricardo, I did include in the chat a link to where is InfluxDB on the cap scale. That's done by this guy named Jebsen, and that's a really cool read if you just want to learn more about InfluxDB. So it's not a benchmark against Prometheus, but I do think it is useful. So how's indexing done on tag set? Are all set tags considered strings? Any plans to introduce geolocation points as tags for improved indexing? We definitely do have plans to introduce geolocation points as tags for indexing. Chris, do you know when that?
No, I don't know when, but there is a clever guy from a company called WayConnect, and I'll send you the link to his talk. He actually just shoved it into, he actually pulled geolocation information and shoved it into the database, and I'll send that to you guys so you can see. So some people have been clever and been able to figure out ways around that.
Can you please elaborate the answer to the question if a script can be used to input data directly into InfluxDB from a flat file? Yes. So if you can take a script. For example, I had some financial data, and I just, for fun, used a script that converted all the data to line protocol and wrote that data into a text file. And then I used the tail plugin to tail that text file. So I was just doing an API call every 5 minutes to some free API that gave me this financial data. And it would get a new point every 5 minutes and then convert that point to line protocol, append that line, write it to the end of my text file, and then the tail input plugin would note any changes that were happening to that text file and write any new points, any new lines. Without using Telegraf, you can just use the any client library to write points directly. So there's a Python one, there's a Node, there's, I don't know, because I only use the Python one.
But yeah,
but
that's exactly it. You aren't using Telegraf when you're using those client libraries. So there's, you can either use Telegraf to bring data in, or you can use the client libraries as Anais was describing. Okay, keep going, Anais, sorry.
I think I don't see any more questions right now, unless, yeah.
Let's just double check the chat, make sure we've got those.
Seems like for me, they're just recycling old questions. I don't know if.
Yeah, let's just make sure. Let's just go. So we still need to get an answer for the micro focus. So I'm going to actually throw that to community right now. I don't know at all. I don't even know what that is. So can you just go through that? And if they're already answered, can you just hit answer live?
Oh, okay, sure. Okay, so no. So I guess, Mauricio, if you want to give some examples of the exact processing that you want to do, to filter. Okay.
All right, so in the chat panel, I posted the webinar for Wakenik, which talks about adding geolocation information. And that was just a clever way that he was able to inject that. And then also, I threw the question about the micro focus operation bridge agent into community, and I shared the link with everybody in chat so we can all learn from that one. Nurajima asked, do you provide any kind of training like 2 days or 3 days where someone can learn it quickly? All the trainings are online, and all the recordings are online, so you can definitely go that way. And let me just provide the link. But the other thing that I'll mention to everybody is if there's any specific topics that you feel are missing, just shoot me a line. I actually got a couple of really great feedback recently from you guys, and that's why we did another capacitor training 2 weeks ago, and that one is already posted.
So Marcio asked if you can give some examples of Telegraf processor plugins, for example, to filter. For any input plugin, you can filter the parameters and limit what metrics are emitted from the input plugin. And that's just configured per the plugin on any input or output or processing or aggregator plugin. So you can include like a name pass and select a certain glob of strings, or a tag. You can include a tag pass or a field pass.
Okay, I just found some docs or some questions about using Telegraf as a router, and the funny part is the comment is that there needs to be more documentation. So I'll take that up as an action item, and I'll throw that into the community as well to get that answered. So did we get through all the questions, Anais? I'm sorry, I've been not completely focused.
Yeah, I think so.
All right, well, we'll keep the lines open for just a few minutes more. I'm going to try to, I want to make sure that I put my question in about Telegraf as a router into the community. That way we can all track that. All right, so here is that link for everybody. I'm also going to talk to the docs guys. I'm also going to put some note in there. Are we good on the questions, Anais?
Yeah, I think the only question that we had was about the microfocus operation bridge agent, but you put that into the community, right? So
I did do that.
So I guess we're good.
Excellent. Okay. If there are any other questions, we'll just keep the lines open for another 3 minutes. Just pop them into the Q&A and the chat. And then if you have any other questions afterwards, please feel free to post them into the community site. Or you can always send it to me, and if I can get them answered real quick, I will. Otherwise, I will also throw them into community and bug some of our developers for the right answer. And I think that's it for now. Looks like you went through all the Q&A, and so we should be good, right?
Mm-hmm.
Excellent. Oh, I see. I see. It's all showing is still open for me, but that's, I think that you've got them all. Okay, cool. So join us again for our trainings next week. I have all the recordings online. You can take a look at those. The trainings are always every Thursday morning at this time. And if you have any other topics, very specific topics, just let me know, and be more than happy to accommodate or make any changes. And we will make sure that we get the questions that are outstanding from today's training answered, and those will be posted in the community site. So take a look there. Thanks for joining us today. We really appreciate it. It's fun to get a bunch of questions, and it's actually fun even if I don't know the answers. I don't know about you, Anais, but then I get to learn something new.
Oh yeah, for sure.
Be able to use it in my implementations of InfluxDB. So thanks everybody for joining us, and you can expect for me to finish the edit of this recording in just a couple hours, and you can take another listen to Miss Anais. Thanks everybody, and have a pleasant day.
Thank you.